saying that some of the norms we're using, you'd find that they were generated from the research that was done in other countries, and those countries, they've got different climatic conditions, they've got different soils, and the management practices that were used there, you'd find that they're different from what we are doing here. So, for example, you might be told that in order for you to grow a particular crop, you need to apply. I'll make an example with fertilizers. Let's say you have to apply maybe 100 kilograms per hectare of nitrogen, for example. And when you look for that information, the source for that information, you find that it is actually coming from another country. And that information, actually, I would say you can obviously use it as a guideline, as a guide, but you might find that it won't give you the crop that you can get in your farm if you just use it as it is and you don't do any test, maybe in your own backyard, in order to see, in order to get the optimum rates for your own context. All right, so which is what normally we would call a site-specific response to your for your crop. So that is why then some of the farmers would actually do their own experiment, or what we call an on-farm experiment, in order to know exactly what's happening in their own backyard. All right, so I said some of these tests, you might find that you just want to test the seed rates or seeding rates. For example, it could be the fertilizer rates that you have been that you found from the literature, or maybe from your neighbors, and then you want to see if it would give you a good crop. Or maybe if, let's say, you raise those rates, maybe you just increase them or decrease them, and see if you're gonna see maybe there's gonna be a different response in comparison to the standard rate that you have received. Yeah, so you may be doing the same thing about the herbicides. Yeah, and any other things that you might want to test. So if, let's say, you want to do this, I'd like to believe that most of us who have been involved in research would be familiar with almost all the steps that you're going to follow here. Because the first step would be to ask a specific question. So you just have to be specific as to what is it that you're trying to understand with your on-farm experiment. What exactly you're trying to do, and it shouldn't be a vague question. I've just have a few simple questions here that I think we might use it as an example. Like, if you look at the first question I have here, you could be asking questions like, does applying a fungicide on maize at V5 increase yield? V5, that is the growth stage of maize. So it could be, you could be asking yourself questions like, what is the optimum seeding rate for maize? So it could be, what is the optimum N rates for maize? You know, I would like to believe that these questions are specific, and it will be much easier to conduct your experiment if you have specific questions like this, or simple questions like this. All right, so once you know the question that you're trying to answer, the next thing you might want to think about is the kind of data that you want to collect. What is it that you're going to collect? This is also very important because it actually informs the design that you're going to follow or you're going to use. Or it's one of the factors that will inform the design that you're going to use in your experiment. Another thing you might want to consider the history of the field you're going to use, because sometimes you'll find that in your field there are patches or areas that you have used in the past, maybe to dump your compost, maybe you used it to mix fertilizers and all that. You might have those kind of patches, and it is important that you are aware of them. You know exactly where they are. You know, generally, if you're doing an experiment, you will try to avoid areas like those. But if it's in your own backyard, maybe you might not want to avoid them, because anyway, that's the field that you're using for your commercial production. So you might want to just, maybe the most important thing might be to know where they are, so that when you're getting a different response from those patches, you would know why you're getting those responses. And other variations that you could have could be maybe soils. You find that soils vary in your area, or in your field, or in your paddock, whatever word you want to use. So you just have to be aware of that. Where is your soil changing? And if you're running an experiment like the ones that you would normally run as researchers or academics, you'd find that we try to avoid those differences in terms of soils when you're running an experiment. But in an experiment where, like your own farm experiment, it's not that important actually, depending on what you want to achieve with it. I believe it's not that important to try and make sure that the whole area is homogeneous, because I mean, that's where you're farming anyway. So I think the most important thing is to know where the boundary is between those different soils, so that in case you get different responses, you know why. You know, especially if it's responses that are not related to what you're trying to test with your experiment. Please, if you have a question or you want to talk, don't just raise your hand, because I won't be able to see it. You can just unmute your mic and speak. Yeah. All right. And then once we have looked at, or we have a good understanding of the field history and the variation within the plots or within the paddock, then we have to decide on the design that we are going to use for experiment. And an appropriate design actually would be determined by what? The time that you have to spare for that experiment, because I'd like to believe that as a farmer, you would be busy and you don't want to take you don't want to do an experiment that's going to be taking too much of your time. I would like to believe. So it would depend on that. And if you have a complicated design, that will demand more time from your side. And another thing you might want to think about is the inputs, because if you have like a very big, an experimental site, then you're going to have a lot more inputs. Like, for example, your fertilizers. If let's say you're testing fertilizers, you might have to buy more. If let's say more than the ones that you'd buy if you just planting for commercial purposes. And then even your pesticides or fungicide, if let's say those are the things that you want to test. So it may depend on that, as well as the space that you have as well. So there are many designs that we can choose from, and I decided not to dig into the sophisticated designs that we normally use in research. So I found this simple one that they call just a one-way strip design. If you look at this simple design that we have here, you would see that you just have one strip and then you have another strip. So what I've written here, I just call this the standard treatment. And then I said the higher rates. It could be higher rates or lower rates in comparison to your standard rates. For example, what I mean by that standard rate, for example, let's say you're supposed to be, according to the recommendations from the laboratory that you're using, or from the agronomist that you're working with. Let's say you need to apply 60 kilograms per hectare of nitrogen in order for your maize to grow optimally. So you might want to use that as a standard, and then maybe raise that value or that rate maybe by 50% or whatever percentage in order to see what happens if you increase it or what happens if you decrease it. So this is just a simple strip, and then it is also important that you might want to actually have repetitions, or we normally call this replications. So have different, you have replications. This actually helps us to cater for the variability that you might have in your field, and actually gives you confidence in terms of the results that you find from your experiments, because you're not just getting that from one from one plot. So if you're getting a particular result from maybe 3 or 4 plots, then you have more confidence in those results. Another example sorry, that I have here, is where they were testing a fungicide. If you look at this, they also have a strip, like they just have strips, but they try to rearrange them here. It's a little bit of a randomization. It's just that since you have only one, just strips like this, it doesn't look like a proper randomization, but it is. So you look at that, you could do something like this. To me, this looks like just a simple experiment. Yeah. The question that we might, I used to ask myself a lot when I see people presenting on experiments where they're using different rates of, like especially fertilizers, to say, how did they get to a point where, how do they arrive at that rates that the rates that they're using? So one of the things that we might want to do is to actually, I've already explained this, say you get the rates, then the standard rates that is used by people in your area or by the that is recommended by your agronomist, and then maybe you raise it by a particular percentage or decrease it by a particular percentage in order to determine, to work out the rates that you're going to be using in your own experiment. And then it is actually generally advisable to have a control treatment. Other people, they'll call it your do nothing treatment. So meaning there are no inputs that you're going to have there. But sometimes you don't have to have like a zero, I would say a zero rates kind of thing where you just don't apply anything in your experiment. You can just use your standard rates as your control. I've seen experiments like those. Actually, I've been involved in some of the experiments like those. Yeah. So when you're deciding then on the number of treatments or the levels that you're going to use, and whether to have what replications, that actually might be influenced by the amount of space that you have. If you have a very small plot that you're going to be using, so you're not going to have as many replications as somebody who has a very big piece of land that they're going to be using for the experiment. Actually, it would be nice to hear from some of you guys. I know some of you are in farms and things like that, and it would be nice to hear how you are doing your own experiment in your farms. So another thing that is important is making sure that the boundaries between your treatments are clearly marked, and everybody in the farm knows where those boundaries are, and they know the value of the experiment. I'm saying this because I've heard my experiment ruined by farm workers in another trial that I had, where we're testing nitrogen and phosphorus, and then the farm workers, they just went into the experiment and applied nitrogen, so that ruined the experiment. So that's important to make sure that everybody knows what's happening there and they know the value of the experiment. It is also advisable to make sure that as you collect, as you're making observations during the experiment, you collect all kinds of information that you can get. You could be driving, passing by the experimental sites, and you see something, you take a picture. You record. You make sure that everything is recorded. Yeah. Even if you make mistakes during the experiment, when you're establishing the experiment, it's important that we record those mistakes, because you'd find that they may affect the result at the end of the experiment. I know that we trust our brains most of the time. We're like, no, I will remember. And sometimes you may remember that there's a mistake that happened, but you might not remember where exactly, in which treatment that mistake happened. So that's why it's just important that we record the things that we're observing. Sorry. And then yes, the treatments have to be clearly labeled, and in order to reduce bias, especially when you're dealing with plant diseases, one of the things that you might want to do is to use codes instead of a full treatment name, because what normally happens, and I've seen this in many documents where people talk about this, let's say you have got 2 treatments where you're applying, maybe you apply the chemical in order to treat a particular disease, and then you have a control. Generally, when you go to a plot where you didn't apply the control, sorry, you didn't apply the chemical, you're expecting diseases there. So you tend to record more diseases from there compared to where you apply the treatment. And where you apply the treatment, you don't expect diseases. So your mind tells you that you're not going to see a lot of diseases there. And because of that, you find that you end up collecting results that are biased. So yeah. And when we're harvesting, obviously you would want to collect or harvest your crops, or collect or measure the yields. This is actually what I wanted to say. You measure the yields and record it separately from the different plots, and even your your subdivisions, in case you had some variation within a particular strip. You might want to separate the recordings or the data from those different subdivisions in order to get to understand what exactly happened, what influenced the differences in terms of yield or the growth that you observed in those strips. Then at the end of the experiment, then the things that the questions we might want to ask ourselves is that, did the experiment work? I think that's a very, very important question, because sometimes you'll find that your experiment maybe your crop was hit by hail, but after that it survived and continued to grow. And at the end of the experiment, you find that you don't get any result. Yeah, it happened to me in 2018. I think some of the colleagues here would know about my experiment that I had in Eston here in KZN. Sometimes you'll find that you had, big rains or good rains, and then they counteract the effect of the experiment, of the treatment that you applied. And you'll find that the experiment doesn't work because of that. And then another question is, do these results tell you something important? Because sometimes you find that the experiment, maybe it looks like it worked, but there isn't much you're getting from it. But if there is something you're getting from it, question is it something that you didn't know before? Or maybe it's just telling you or confirming the thing that you knew before. And then some of those, if let's say there's something that you learn from it, obviously you would want to incorporate it. Maybe actually to incorporate it. The question is, how are you going to incorporate it in the future? Because there must be a plan as to how you're going to do it. Another question could be, do you have to have another experiment similar to this one or a different experiment to answer some of the questions that were raised by the experiment that you've just completed? And in terms of the analysis of the results, I would say, I know that most of us would like to use the sophisticated, softwares. I believe that in an on-farm experiment, you can actually use Excel because there's a lot of functions in Excel that would give you good results. I actually done some comparisons. Actually, was comparing Excel with other softwares, even SPSS and JESP and many others. You'd find that some of the time, most of the time, actually, they would give you the same results or similar output. So yeah. And then in closure, the things that you might want to think about is that do not expect too much from your first experiment. Generally, you'd find that you don't get much response, especially if you're growing a crop and doing some fertilizer and nutrient tests and things like that. Sometimes you don't get the response in your first crop. Actually, I'm sitting with data at the moment where from my experiment where I didn't get any response at all after spending 2 years waiting for it for the data. Yeah, and then you should not expect or you might not want to expect the answer to jump at you from the raw yield results. So you just have to take time to play with the data in order to actually see what you might want to see from that experiment, from the experiment that you have done. And then it is also advisable to actually separate out treatment's effects from the noise that you would see in your data, and it's much easier to see to separate the treatment's effects from the noise if you have been recording everything that you observed during the experiment, because some of the noise might be coming from the things that happened during the experiment. Yeah, and in one of the experiments that I had, actually we had a trial, and then just above the trial there was a compost heap, and then there was a big rain that came, and then it washed the compost into the trial. So we had to walk in each and every plot recording where we saw that compost that was washed from just up, just above the trial site. So it is just very important to make sure that we check this. And lastly, we might want to think about the interactions that happen during the experiment. And I know that here I'm focusing mainly on crop enterprise. So there are interactions that may happen in during the experiment. Like, for example, if you look at the response of superphosphate, which is normally used as a source for phosphorus, the response of superphosphate can be increased by increasing seed rates, for example, because you would know that denser plant population might squeeze out weeds on better fertilized soils. So there are many other interactions that may happen. So it's important to actually think about those as well during the experiment. Okay, so that's all I wanted to share about, with the hope that somebody will have something to think about. I didn't get any comment or question. I hope now we can just hear what you guys think. If there is something that you'd want to say.
Sir.
Yebo.
Yes, I don't know what is your take on this one, but thank you for the presentation. I'm just probably I'm starting to be negative on these things when you've done so much of them. I'm starting to feel that there are actually parameters that I don't know if I must say by nature, you do a lot of work and only to find that at the end there are no differences. For instance, something that you will know very well, and you mustn't be mad at me, that AFNO method for aggregate stability.
Yeah.
There are 3 different approaches. My experience with such is that you know how painful that method is, but every now and again you find that there are no differences between those. So I wonder if actually is it worth us doing all those 3 different approaches under the AFNO, because I'm starting to feel that by nature it's just it's too much work, but for nothing at the end of the day. But I also want to hear your experience about it, because I know you've done that a lot as well.
Thank you, Pussy. Actually, I know exactly what you're talking about. With regards to that method, I normally focus on one, the first treatment, the water treatment. That's the one that would normally give you meaningful results generally.
The aggressive one.
Yes, but the other ones, no. And yeah, but I think maybe the reasons that I think, the things that I think are the reasons for that, I don't know, maybe we could talk about that maybe outside this platform. But I've never actually, I started doing that thing a long time ago, using that thing a long time ago, but never, obtain significant results, or when you look at, from the other 2 treatments. Yeah.
No, thank you. I'm happy to hear that, because I was thinking maybe I'm losing it. or
Nah. Yeah. No, thanks.
Thank you.
Sorry, Dr.
Yebo.
Yes, I'm not sure Noma Bengozera or something, but I heard you mentioning something about the noise interrupting the experiment or something. Can you explain that? How kwenzeka kanjani?
Okay, So when we talk about the noise, I mean, what exactly am I referring to there? When you look, you have measured the data, or sorry, you have collected the data. Sometimes you'd have, let me make it, how can I make an example? Let's just say you have collected the data, and most of the values that you have, maybe, let's say, maybe they ranging between, let's say, 5 and 10, okay? And then all of a sudden you have a value that just shoots and go, maybe it's around 30 or something. All right. Maybe you have another, or maybe 2 or 3 values that are sitting at about 50, you know. So you'd find that those values, they're not as a result of the treatment that you applied, but they are as a result of maybe the variations that were there in that treatment that you applied. Maybe another example that I can make in order to try and simplify this. Let's say you applied fertilizer, like 50 kilograms per hectare of fertilizer, and then on a strip. And on that strip, maybe you have got 3 different soils. All right. So the response that you find from that treatment might not only be due to the treatment that you applied, that fertilizer you applied. It could be because of maybe the different soils that you had in that strip, or they might have been influenced by those different soils you have in that strip. So the noise, I'm talking about the values you have, the results you have, which are caused by that variation. I don't know if that makes sense, or there's another colleague who can explain that better.
Now I understand what you're talking about. Thank you.